Dear students, in this session I am going to discuss about graphs, means the questions and the problems based on graphs in one dimensional motion, how to solve. Okay. So, whenever you come across a graph, right, you can obtain some data from the graph from mainly three ways. One is you can obtain some data from the slope, other one is you can obtain some data from area, other one is by writing the equation corresponding to that graph. Okay, you can obtain the relationship between the physical quantities that are mentioned. Okay, with the help of these three, right, we can solve any question or problem based on graphs, right. So, first of all, let us discuss about slope. Okay. Usually this is represented by the letter M. Okay. It is defined as tan of angle made by the graph with positive x axis, means here theta is angle made by the graph with positive x axis. There is also written as dy by dx, means slope of the tangent drawn at that point. Then it, now if you observe, the rate of change of slope represents what? Means variation of slope with variation of x coordinate. Okay. This is, I can write it as d of dy by dx, which is nothing but, it can be written as simply d square y by dx square. Okay. Now, I am going to discuss about these two terms in different situations. In which situation this is positive, this is negative, this is 0. Similarly, in which situation this is positive, this is negative, this is 0, that we will see. Okay. For that, if you come to one example, say the graphs are like this, right, means straight lines are given. Then first point, what about its slope? Slope means tangent of angle made by the graph with positive x direction. This is positive x direction, with this at this point it is making angle theta, means at this point also it has to make an angle theta, here also angle is theta, because as it is a straight line. So, tan theta value here is same, indicating that tan theta is constant, means slope is constant. So, for all straight lines you can conclude slope is constant, isn't it? And if you come to second point, that is whether slope is positive or negative or 0. Okay. Here for all these figures, if you observe, the angle made by the graph with positive x direction is less than 90 only. As it is less than 90 means tan is positive, hence I can conclude that for all these straight lines slope is positive. And the next thing is, what about d square y by dx square, means first derivative of slope, isn't it? See, as m is constant, this is representing differentiation of m with respect to x. As m is constant, this differentiation must be equal to 0. Okay. Next, if you come to another example, say the graphs are in this manner, straight lines are like this. Okay. If the straight lines are in this manner, if you observe, as it is a straight line, means first conclusion is slope is constant, and the second conclusion is at any point with positive x direction, if you observe, angle made by it is greater than 90 degrees, indicating that tan is negative, means slope is negative. So, here slope is negative. And if you come to third one, okay, regarding d square y by dx square. Okay. So, here if you observe, as slope is constant means obviously this should remain, slope is constant means this is nothing but differentiation of slope with respect to x. So, as slope is constant, this value is equal to 0, isn't it? Now, if you come to another example, say in case the graph is in this fashion. Okay. In this situation, if you consider the point, say this is O, this is A, this is B, somewhere this is C. Okay. Now at a point P, if you want to find out its a slope, then what to do? Simply you have to draw a tangent at that point. The tangent will behave like a straight line. We know for straight line how to find out the slope, means angle made by this tangent with positive x-axis you need to find out. Okay. Tan of that angle is nothing but slope. Okay. Here it is clear that tan of that angle is that angle is less than 90 degrees, means tangent of that is positive, means slope is positive. And one thing is clear, if I move to here, the tangent will be like this, indicating that angle made with positive x-axis is changing. Hence I can conclude that here slope is not constant. And second point is slope is at P, if you consider, okay, slope is tan theta, which is positive. And third one, for O to A, what happens to d square y by dx square, means indirectly I am talking about what happens to slope. Okay. As I am moving from O to P, it is clear that x coordinate is increasing, so this is positive. Okay. Based on whether this is positive or negative, we can come to the conclusion that the derivative of slope is positive or negative. Okay. For that, if I move from O to A, what is happening we have to see carefully. At O, if you observe a tangent, it is like this, and at A, tangent is like this, indicating that initially tangent is in this manner, after that tangent is becoming like this. Okay. Means it is said to be moving towards the positive x direction, indicating that theta is decreasing. Theta is decreasing means tan theta decreases, so slope decreases. Slope decreases means change in slope is negative. So negative by positive, this whole thing leads to negative. Then it, and if you come to a point, say Q, right? At this point, what is happening means, if you observe, this is the tangent, okay, and angle made by it with positive x direction means this angle. It is clear that that angle is greater than 90, means tan of that angle is negative. Hence I can conclude that at Q, slope is negative. Then what about d square y by dx square value? Okay. Here if you observe carefully, as I am moving from A to say somewhere Q, okay, at A tangent is like this, later tangent is like this, later tangent is like this. Okay, now means initially tangent is like this, after that tangent is becoming like this and like this, means with horizontal, if you observe, it is said to be moving away from horizontal, means angle with positive x axis is increasing, indicating that, okay, tan theta is increasing, so slope is increasing, means dm is positive, hence d square y by dx square comes out to be positive. Okay. So these are the points to be remembered regarding the term slope. Now we will see one example where we can apply these principles. See, if at all the situation given is like this, say x t graph is given, in this fashion, say it is O, A, B, C, D. Now he may ask you what happens to velocity, okay, and sign of acceleration and sign of velocity. Okay, for different parts. Then it, for that, if you observe, as position versus time graph is given means, first of all I have to think slope is going to represent which physical quantity. Okay. Here slope means change in y coordinate, but here y coordinate is represented by position x, so dx upon change in x coordinate means dt, but we know dx by dt is equal to velocity. Okay. So, slope is giving velocity. Now, rate of change of slope represents what, that I will see. Okay. That is nothing but d of velocity with respect to t, which is nothing but d square x by dt square, which we can call it as acceleration, because dv by differentiating velocity with respect to time you will get acceleration. Okay. So, if you observe the part O to A, okay, at any point if you draw a tangent, the angle made with positive x direction is less than 90, indicating that velocity is positive. Slope is positive means velocity is positive. Okay. And the next thing is, from O to A, what happens to slope? As at this point the tangent is like this, later like this, later like this, later like this, later like this, indicating that the tangent is moving towards the horizon. Okay. Indicating that theta is decreasing means slope is decreasing. As slope is decreasing means I can conclude that velocity is decreasing, and okay, slope is decreasing means this is negative, indicating that acceleration is negative for this part. Okay. And next, for A to B, if you observe, right, A to B straight line means slope is constant, means velocity is constant. As velocity is constant means acceleration is 0. Okay. And next thing is, of course, velocity is positive, you can conclude. And if you come to B to C, okay, for this part what is happening? Tangent at this point is like this, later it is like this, later it is like this, later it is like this, means the tangent is moving away from origin, means theta is increasing, so slope is increasing. Okay. Now, from B to C, at any point if you draw a tangent, the angle made is less than 90, means velocity is positive, but acceleration is negative. As okay, sorry, velocity is positive and slope is increasing means velocity is increasing, so acceleration is positive. Okay. Slope is increasing means dm is positive, so obviously acceleration is positive. Okay. And C to D, if you observe, x is same, okay, indicating that position is not changing, means the particle is at rest. Particle is at rest means you can conclude that velocity is 0, okay, obviously acceleration is 0 in that case. Okay. Like this, with the help of the concept what we discussed, okay, we can analyze the graphs, isn't it? Now, another example he may mention you like this, that is two graphs, x versus t graphs for a body A, for a body B are as shown. This is 30, this is 30. Now, he is going to ask what is the ratio of their velocities. Okay. In this situation, how to find out velocity means, here it is clear that slope of the given graph represents dx by dt, which is nothing but velocity. So, slope is nothing but velocity. So, velocity of A means slope of A means tangent of angle made with horizontal upon, okay, velocity of B means slope of the point graph B. Slope of the graph B means tan of angle made by it with horizon, that is 60 degrees, which leads to 1 by 3. Okay. And not only this, if he is talking about velocity versus time graph, okay, that graph is in this fashion. Say this is 0, this is some 4, this is some 6, this is 8, 10, 12, okay, and this corresponds to some 20. Now, he is going to ask you what is acceleration at t is equal to 3 seconds. Okay. If you want to find out acceleration from velocity time graph, first of all I have to think what is its slope. Slope is giving what? change in y coordinate means velocity, with respect to change in x coordinate means time, but dv by dt is nothing but acceleration. So, here slope is nothing but acceleration. So, acceleration is nothing but slope of the curve. Now, he is asking slope at t is equal to 3 seconds, means at t is equal to 3, it is somewhere here, means at this point slope, but it is a straight line. As it is a straight line means slope is same at all points, means slope of this straight line finding at this point or at this point or at this point, it will not matter. So, from the figure it is clear that it is easier to find out its slope at this point, say this is making an angle theta, then acceleration is slope, that is equal to, here slope means tan theta refers to opposite by adjacent, opposite refers to how much? 20 upon adjacent refers to 4. So, 5 meter per second square, that is acceleration. Okay. Similarly, what is the acceleration at t is equal to some 7 seconds? T is 7 means somewhere here at this point, if you observe slope, okay, its value is equal to 0. So, I can conclude acceleration is 0. And similarly, he may talk about acceleration at t is equal to some 10 seconds. Okay. At t is equal to 10 seconds means at this point I need the slope, but it is a straight line means its slope at this point is similar to here also. So, I will take this angle is some theta. Okay. Then slope means tan of angle made by it with positive x axis means this angle, that angle is 180 minus theta, that is equal to minus tan theta. So, minus of tan theta means opposite 20 upon adjacent 4. So, here we will get minus 5 meter per second square. Okay. Like this we can proceed for the problems based on graphs, especially slope concept. Okay.